Hi everybody. So today we are going to look at what multiple slit interference. Okay, so this is just an introduction to this multiple slit interference. What we have been looking at so far for interference is when there are only two slits or two gaps, and what happens when waves or semicircular waves interfere through them. Now, if instead of two slits, you have a whole lot of them, like literally hundreds and thousands of them, something like this. Okay, so this is what we call a diffraction grating. So that means instead of just two sets of waves interfering with each other, you have hundreds and hundreds of little waves, wavelets, semicircular waves interfering with each other. So as a result, the pattern formed with a diffraction grating is quite different to the pattern formed with two slits. So with two slits, the sort of pattern we get it's quite fuzzy, and the fringes, these are quite close together. Whereas for a diffraction grating, you find the fringes are really well defined, they're sharp, they're bright, and they're widely spaced. Now there's a reason why that happens, and that's because, first of all, because there's so many gaps or openings or slits, more light can come through, so that is why they're brighter. Now there's something called slit width, and there's something called the distance between slits. So I tried to show it in this diagram. So let's say that's a diffraction grating, and these gaps are the slits. So the slit width is how wide is this gap. Okay, now because the slits are very narrower the slit, the more the diffraction. Okay, so when it's narrow, diffracts more. And D is what we call the distance from the middle of one gap to the middle of the other. That's your D. Okay, that's called slits, the distance from one slit to the other. Okay, now when this distance from one slit to the other decreases, because there's so many of them, what happens is that these fringes are widely spread out. So they're just not limited to here, but you get them spread out over a bigger range. Okay, so that's the main difference between a diffraction grating and two slits. Now it's still interference. So, and here I've just drawn a diagram here. So if it was two slits, they just diffracted through that much. You get all your pattern just limited to that area. But if it's a diffraction grating, the angle is much bigger. Okay, so I've just drawn, so the angle of diffraction is much larger. So your fringes are much widely spread apart. You still have your order numbers. So the central one is N0, the one on either side is N1, N2, and so on. So we can still use the same formula with the diffraction grating, where you can use N lambda is D sine theta, where N is the order number, lambda is the wavelength of the wave, D is the distance from one slit to the other, and theta is your angle of diffraction. That's the angle between your central antinodal line and whatever. Okay, so often they don't give you the value of D, but they give you the value of N, which is the number of slits per meter. And so you can get D by using 1 over N. So when I say number of slits per meter, typical diffraction gratings have something like 600 lines per millimeter, okay, or 300 lines per millimeter. So we've got to convert that to, so if it's 300 lines in 1 millimeter, how much will a meter have of them? So it's 1,000 times more. So which will come up in the questions we're doing. So there's no new formula, but it's just you just need to know what happens when there's loads and loads of gaps as compared to just having two gaps. And so that's the formula we use, and I will upload the notes. And there are some questions to do under multiple slit interference. The very last one has to do with white light. So don't do the last question, do all the others. And the next lesson following this is about diffraction of white light. Okay, so bye for now.